So we're gonna move forward with the next speaker. It's Dr. Muhammad Abdullah. He's from University of King Abdulaziz University. So the floor is yours. Please go ahead.
Hi everyone. My name is Tuerdimanimaiti. I have worked as a postdoctoral research fellow under supervision of Professor Adnan Mimic since 2019, and I'm currently looking for the new position. In this poster, I would like to introduce you a novel multifunctional wound dressing materials composite of only natural biopolymers. And I'm also pleased to inform you that we have applied for a US patent for this work last year, and we got granted in this January. Wound healing is one of the primary concerns in medical field because of frequent occurrence of wounds and injuries and burns and rapid growth of chronic wounds and aged population. Cryogels is one of the most promising materials for wound healing application, but some of the challenges such as surgical site infection and high level oxidative stress has to be addressed properly. In this study, we developed a Cryogel composite of only natural biopolymers, lignin and gelatin. Among them, lignin is one of the most abundantly available yet underutilized biopolymers originated from plants. On the other hand, gelatin is one of the major component of skin tissue, and it has been widely studied for wound healing application. In this work, we chemically cross-linked the lignin gelatin mixture at -20 degrees. After throwing this, it resulted in a macropore structure in which the pore size is between 80 to 120 micrometer, and the pore interconnectivity is above 75%. This Cryogel also increases its weight up to 12 to 17 times after swelling in water-based media. Next, we evaluated the effect of lignin addition on mechanical property, and we found that 0.2% of lignin can significantly increase in elastic modulus and mechanical strength of the material. And later on, we did the injectability test, and we found that lignin with 0.1 and 0.2% could give the best shape without any shape loss after injection. Then we did the microbial test, and we found, interestingly, the Cryogel with 0.1% of lignin showed the best antimicrobial performance. And finally, we did the antioxidant test, and we found that it is actually proportional to the lignin concentration. Overall, this approach shows great promises for the design of bioresource-based multifunctional cryogels for wound healing and other biomedical applications. Thank you so much.
I have a question here for Dr. Muhammad Abdul about the antioxidant and antimicrobial self-healing. What is the time frame basically for self-healing of the cracks on the material, and what is the thrives basically? So it's a biological process, so you have to have substrate to make that process going on. So you can either speed up the process with some sort of catalyst, or you can hinder the process. So
sorry, what is your question again? I didn't get it.
So the time frame for a self-healing material.
Okay.
So because it's an antimicrobial, I think it's a microorganisms. So basically it's a biological process that is going to have some substrate to feed on so they can self-heal.
Yeah.
Yeah. So and that frame, so what is the optimal time frame that you expect for such process?
This should be depend on, you know, the condition, like what kind, because here what we are doing about the wound healing, and you know there are the different kind of wounds, and basically we are in the material side more actually look about something which is actually needed for the wound healing application. Like, for example, there should be some infection goes on. So how can we remove this infection? And as I told you about the antioxidants, it is actually about, there is a lot of like free radicals, which actually causes a lot of problem. Actually, it actually cause the death of the cells. So we would like to, to give this standard. So for that, and it is actually should be depend on different system, different type of wounds. It is acute wounds or the chronic wounds, and what is the size. We cannot say like directly, but it is all depend. But the main point is to if you have some material with more functionality, which actually capture all the requirements for the wounds, it should be the best. This is our idea.
Okay, thank you very much. Thank you for your time.
You're welcome.